Yeah, so today we'll be talking about this week's session, which will be about deep reinforcement learning. So you people have heard about deep reinforcement learning. So what we'll do, we'll first do some background knowledge about what is the deep learning and why it is required to be merged with reinforcement learning. So these two terms become deep reinforcement learning. We'll learn what is new about the deep reinforcement learning and a few questions related to the deep RL and assignments. Right. So this will be the agenda of the today's lecture. So just to recap few previous things, there were three approaches for reinforcement learning. The first one was value-based RL. The second one was policy-based, and another one was model-based. If you see, there are three kinds of algorithm. Value-based, inside value-based you'll find Q network, deep Q network and all those. In policy-based, policy gradient you will find there. In model-based, it's a kind of different thing. It's like a building a model of the environment. In above two, we don't have any knowledge about the environment, we are just exploring. But in model-based RL, you assume that model, you also model the environment. Means you will have the information about the model itself. So this is the another kind of RL algorithms. Now coming to quick review about value-based and policy-based algorithms. Because whenever you go, you need to choose one of them. Either you should go with the value-based or with the policy-based. So given the situation, which should you take? It depends, right? Do you want to maximize your there are two things. One is, do you want to make it converge the algorithm faster, or do you want to go for optimal one? So based on that, you choose whether you should go for value based or policy based. So this is the main distinction you do. So in left hand side, you can see for a value based function, you give two information to a network, state and action, and finally it says what is the quality of the action for the given state S. Whereas in policy based RL, what happens, you just give state information to network, and network will say which action you should take. So that's why I used to call it, in policy based you have directly, you are optimizing your network. You are nothing is in between. But here in value based, you are giving state and action, and then checking what is the value of the action A for state S. If you enumerate it over all A, you will have the information that which action is giving the maximum reward, and you select that action. So this is how in value based, it's a two-phase process. First you are finding QSA, and then you are choosing which action to take. But in policy based, you are just giving state and you are getting action, right? Which action you should take. So say this is the general difference between these two. So people already know what is the Q learning. So I am giving a bit, just little bit this equation. This equation is very much Bellman equation. If you heard, that's fine. Bellman equation, TD error. These are very crucial component of Q learning algorithm. So what TD says, temporal difference says. So this is the temporal difference, if you see. So idea is that I'm exploring, let's say. So whatever learning I have, it's most likely after 2 days my learning would be better. Something like that. This is the temporal difference. So whatever estimated I have estimated now, and whatever I'll estimate after 3 days, more likely that whatever I'll do after 3 days would be better. And this difference would be temporal difference, or the loss. If you see, this is the temporal difference. So I think you are getting the intuition what is the temporal difference, and you are just back propagating that information, that why that network was not able to estimate the whatever currently it is estimating. So that loss gets back propagated and model learns accordingly. Now coming to important terms in Q learning, there are few important terms. One is state. State is your what is the current situation. Action is what are the possible action you have. Which action should you take? Action means what, given a state, what behavior you will do. It's an action. Reward means for a given state, and whatever action you will take, what reward you are going to get it. Well, it might be positive, it might be negative, so don't confuse it that reward cannot always be positive, it can be negative as well. So it's all reward here, it is a general term which can also be penalty. Now coming to episodes. What is episodes? When an agent ends up in terminating state cannot take a new action. This is called one episode has been done. Means it starts, for example, I started a robot in a room, and its goal is to go to gate, and if it is going to a wall and stuck with that, this is also a terminal state. If it touching the wall, it is the terminal state. Then the episode would be from wherever it start, either touches the wall or reaching to the goal. This will known as an episode. Now coming to Q values, used to determine how good an action A taken at a particular state S is Q. So Q value we discussed already, quality of action value, right? Now coming to temporal difference, what is the temporal difference and all, let me come a bit here. So a formula used to find Q value here is like a formula used to find the Q value by using the value of current state and action in the previous state. So temporal difference would just whatever intuition I gave you. If I'm learning, more likely after 7 days my learning or the estimation for something would be better compared to today's, and just we are doing the difference and passing it. This is known as a temporal difference. Yeah, so temporal difference, whatever I said, it is the temporal difference, means what estimation you are doing now, and whatever estimation you will do after 2-3 days. If you are learning, then more likely the later one will be more appropriate, and just do the difference between these two and back propagate. This is the idea. What is policy? Policy is just mapping of state to action. So this is the basic definition of any policy, and whatever you learn in this whole RL course, it will be evolve around this one, what is policy and all. So please make sure you are getting the point, what is the policy. So Q learning, if I have to explain in very simple term, what you do, you make a Q table, and in rows you write all states, you just enumerate them, and in columns you enumerate all action, and each entry means a essay, right? So that essay says how much appropriate the action is for given state S. So how it is learned? This is the idea how it is being learned. So in initialize Q table, this is how you initialize, make it everything to 0. So make everything to the 0, and then you first step is done. Second step is select an action to perform A. Now whenever you are learning at the starting, you do exploration. Exploration means you have 5 action. I'll say take any action at a time. This is called as exploration. You took an action, perform the selected action, you execute the action in the environment, then whatever you will see, you will reach to another state S dash, and you will get some reward. So measure that reward, and then update a Q table. So Q table will be updated with this equation. Q of new would be QSA, means whatever the previous you have, what it is 0 here, so 0 plus alpha into, and this difference, what reward you are getting currently, plus gamma times this term. So max of, you will go to another state ST plus 1, so you take this value. Fine, for taking action you are going to ST plus 1. For ST plus 1, see which action is giving a maximum reward. So you calculate this value, max of A, S of T plus 1, minus old value, whatever initially it was in table. So it will be 0 here. So alpha into this term, whatever it will be updated here, whatever value you are calculating. So this is how iteration works, right? Now coming to the characteristics of Q learning. The discount factor, this is very important term. I used to say today's 20 rupees, is it more is equivalent to 20 rupees after 3 years? Most of you will say no, and that's true, it will not be equal. So this is the idea of gamma. Gamma says you consider future reward as important, but not as important as your immediate reward. So if gamma would be 0, means what does that mean? You are very short-sighted. You are not considering future reward at all in your consideration, right? If gamma will be 1, then you are considering current reward as well as the future reward equivalent, which is also not good. And this graphs, if you will to see, if you are taking gamma as 0, so what is the reward you are getting, and if you are taking gamma as 1, whatever the reward you are getting right hand side. So if you are taking gamma 0 means you are short sighted, you are considering only current reward. And this is, if you see the graph, it is being converged, but converged at the negative value -25, means you are not learning at all. You are not learning at all, because you are not doing much whatever immediately saying I got -5, okay fine, you are not considering the future reward from that state. This is the problem here, it is happening. But if you are considering every reward equally important, then also you are again stuck at some value, conversing but at some very positive value, 0.1. But if you will consider gamma at 0.9 or 0.8, then you will find the curve will look like something like this. So here it may converge maybe at 200, maybe at 400, something like that, depending on the nature of the problem. So neither gamma 0 is good nor gamma 1 is good. It depends on the problem, and you need to, usually gamma used to be 0.9. Okay, so that's cool. Till then we have learned what is MDP, what is reinforcement learning, and finally now we are coming to deep reinforcement learning. So I don't know if people know about reinforcement learning, deep learning or not. So let me make sure you are on the same page. Otherwise, if I discuss deep reinforcement learning and you people don't know deep learning, then it may be difficult for you to catch. Right. So let us go and discuss about that as well. So I'm seeing if I have some slides for deep learning, so that I can give you the basic idea, so that you will be able to connect these two terms and will be able to do this. Yeah. So coming to a bit about philosophy, so we started with rule-based system, then we came to machine learning, and just before 5-7 days it's become an era of deep learning. What deep learning says, it says you don't do feature engineering, you just give me input and output, I'll learn by itself. You don't have to do feature representation also. Just give input in raw form, output in raw form, and I'll do the deep processing of that input and will lead to finally do the output. So there is nothing like a black box. People usually say deep learning is a black box. At some extent it's a black box. If you'll go towards the mathematics, it's just algorithm which is very hard to do the calculation pen or paper, something like that. That's why there is something it's missing, but it's completely mathematical. So why deep learning? Why not reinforcement learning was enough? It was working fine. If you see, there was a problem was with the Q learning. We had a table, but if you have lot of states, what you will do, you have to store S cross A matrix, and which used to be very space costly. This is one problem. Second problem is too slow to learn the value of each state separately. So it is saying algorithm was conversing, that's cool, okay, but it was taking too much time to learn the value of each state separately, because we are doing all state and all action and their combination we are trying. Third one is we need to generalize what we learn across the states. We need to that point's also valid. So whatever you have learned, that's fine, you have to do the generalization as well. So use deep neural network. So before few slides I discussed there are mainly two kinds of algorithm, value based and policy based. Another one is a model based, but It is I haven't used in my work, so I'm a bit less familiar with that. But value-based policy-based I was quite comfortable. In model-based, you also model the environment, so you have something about idea about model, and that information also you use while learning an optimal policy. So this was the transition from Q learning, from table to going to deep learning was like that. The table is replaced by some network, some hidden neural network, and you are saying, okay, you don't have to do a lot of calculation. You just give me state, and I'll say what will be the Q value action for 1, Q value action for 2, Q value action for n. I'll give you like that. It will in output space there would be n bit vectors, and n is number of actions, so it will give you the value for each action, and you select the action which is giving you maximum QSA value. Fine. So let me see if, yeah, so why deep reinforcement learning we talked about. Advances in deep learning also. So in last few years, if you see, the deep learning field has grown leaps and bounds, right? So why not to exploit that information? This was also another motivation for using deep reinforcement learning rather than reinforcement learning. Advances in reinforcement learning, we have also advances in reinforcement learning. So advances in computational capability, this is very important. This was the bottleneck. Deep learning was there since 2000, right? But we don't had that much of computation capability, and that's why we were waiting. But now, just before 5 or 10 years, we have a lot of computation, and finally we are able to execute whatever we have formulated for the deep learning, and that is becoming easy, and that makes it feasible to be employed. So if you please see this slide. So what we are doing, this was the reinforcement learning. We are giving standard computer vision image, finally finding out the features, and that feature was going to network, very simple network SBL, and it was saying which action to take, right, kind of, or what is the value of that action. And deep learning says no, don't do that. Fine, you just give me image, I'll learn by itself. So if it's just giving raw image, and finally there is some convolutional network, and it is saying whether it's a tiger, whether it's a cat, whether it's some other animal. So it is able to say which animal it is, right? Now coming to standard reinforcement learning to deep reinforcement learning, if you see, so feature was one thing. If you are able to observe things, feature engineering we have to do. Given an image, we have to do features, and then finally the traditional reinforcement learning algorithm works. But in deep reinforcement learning, it says no, don't do feature engineering, I'll internally do myself. So you can think this network as feature engineering plus reinforcement learning, both are it's doing inside that. And finally it is saying whether it should, given the current state, whether it should go left or right. This is what it will say. Why deep reinforcement learning? So the image, if you see, I have clearly explained this image here. So you have the tiger image, finally you give this image to a network perception, it will do, and finally to say what it is. It will say it is a tiger, fine. So what, in given the tiger scenario, what you should do? The probable action is stay there, run away, or something like that, and finally the action which is being selected would be run away. So this is what it is happening. So these two steps has been merged. Don't think it as a two different steps. It will be simply merged. So whatever you're saying, convolution above and this neural network, it was the traditional approach where you have to do feature engineering, and then finally convolutional network, you'll find out the information. Finally, with the deep learning, we just give image if you have trained in such a way that from image it will say what should you do. Another example was this: given the observation, what action you should do, for whether to go left or right. So this is one example. You have observation state O1. From O1 you have some pi. You are taking action A. You are going to state S2. So pi is giving saying which action you should take for O1, and then it is Markov property. I just revise you. Markov property says you are at, let's say, O2, and you have to take what action you should consider. Don't go previous. Just you have whatever the information you have for O2, it is good enough to say that what you should do, right? It doesn't require you to go learn something about O1 or something like that, right? It's good enough to say what you should do in that state. You have Markov property which says your future is independent of past, whatever the information you have, that's good enough to do whatever you should do now, right? So you don't have to go back, right? You just do that, right? So what we have here, imitation learning, I don't know whether you people know, it's just another name of supervised learning. Imitation learning will have input output pair and from where it will learn. But what is the deep reinforcement learning? You are saying this is how the deep reinforcement learning works. In the below sheet, if you see, you are giving OT observation state, you are taking what action you should take, you are putting it into training data, and then you will do the supervised learning. Supervised learning says you will need input and output level both. So this is OT and AT, right? But in deep reinforcement learning, it is not required. It will interact with the environment and then get to know whether it was good action or not. If it gets penalty, then says okay, find the given state. I shouldn't do that. It will learn like that. From by interacting with the environment, there is no external supervision for that. So there, whatever the term I said, it is the reinforcement reward function. So if you see, which action is better or worse, who will decide? This is the reward function which is going to say, right? Which action should I take? So it says for you take an action A which is giving you the maximum reward at that time, not at that time, not only immediate but overall. So please make sure it's known as a cumulative reward. So there might be a question, given the situation, what you should consider about reward, future reward, cumulative reward, or it's independent of your answer would be cumulative reward. You consider the cumulative reward and then finally decide which action you should take. Tell us which state and action are better. So let's say consider this situation, someone is driving, and then finally if you are just going smoothly for each 2 seconds, let's say I'm considering unit as 2 seconds, then you are saying okay, I have drived well, right? So I should get reward for that. But in 2 seconds you just got someone else also came and just a strike happened, then you get to know whatever action I had done, action was left or right, maybe speed as well. So it will get to know, given the situation, I shouldn't do that. So it will learn like that. Yeah, so there are few potential application, I should say, for reinforcement learning. What something struck in my mind when I heard first thing, it is robotics. So in robotics, it's heavily used. You make something like a humanoid, which will learn again like a human. Human learns through interaction with the environment, like trial and error approach. So this is how it is being, two things are connected. You all people have heard the term autonomous driving. What does that say? Autonomous driving. Autonomous driving says you will have vehicles and it needs to reach to the path, reach to goal state automatically. Nothing should be come in between. So how will you do that? You need to train the model. How let's say you starting the training, you are putting this vehicle on the road. But obviously you cannot do this in real world, it will lead to lot of loss. So you do simulation. You are putting this vehicle into some simulated environment and it will have, let's say, 3 or 4 action: left, right, speed, and all those things. And state would be a general, road. So if it will strike with something, you are giving penalty. If it is going smoothly for a few seconds, you are giving reward based on that. And this is how, if you'll now put after training into the real world, it will able to do the task, because it has learned what it has learned. It has learned, given the scenario, whether it should go do the speed up, whether speed down, or whether I should do left, right, or stop, like that. This is very popular technique. It's already employed by Tesla, and now it is in market. I don't know when it will come for available to the everywhere, but now it is available in few countries, particularly Canada. I heard that they are using this kind of technique here. Now coming to the language and dialogue structure. So in dialogue also, people use to this technique called reinforcement learning for dialogue management. So this is language and dialogue structure, how to learn. So dialogue is also kind of similar to RL environment, because given the state information, for example, I'm talking with you, given the scenario, what would be my next sentence? It depends on whatever I have talked till now, right? So this is called history, dialogue history. Given the dialogue history, what action should I take? Should I say something? Should I stop? Should I ask question or something like that? So it depends on dialogue history. So state would be dialogue history, and action would be what would be the next sentence, which will be collection of words here. In finance, in Atari game, this is very popular term, Atari games, for deep reinforcement learning. It has beaten lot of experts who were the world champions. Now this autonomous agents has owned the game with them as well. So you can imagine where we are now. So whatever I have talked about, that Q learning algorithm, that table, this one, if you see, now I'll explain through deep reinforcement learning how it learns. Where it is, this one I'll say this action and all. Finally, how you can do with the deep reinforcement learning. Yeah, so this is how it does. So if you see at the top, it is the illustration of Q network. You are giving state and action, and finally you have some function which will say what is the Q value. Fine. So neural networks are the best function approximation. So why you should do with using the table? Why not use some network neurons to do the optimization? This was the idea. Which is, rather than that function, you put some approximate neural network, and it will give you output like that. So if you can see Q value for S, A, T, A1, A2, AN. You have an actions, and finally it will say. I'll select A5 because Q as a value would be comparatively higher than any of the action. Then I'll take A5 is the most appropriate. So what happens if you see in these two approaches? First we do initialize the Q table. We choose action and we update Q table using the Bellman equation, right? But here in deep learning, you initialize the network parameters, network weights. This network looks like this. You are not going to initialize in Q table. You are just initializing, you are initializing that network. You are choosing an action. That's fine. Choose an action. From this, you can see QSA. Update your network weights using the Bellman equation. That error, whatever you say, the TD error, that will get back propagated. So just giving an example how it is being done. Let's say you are asking what is the cost of this bike. You asked me and I said it is 50,000. You laughed at me and said no, it's too high. So I came to approximate something saying 90,000. You said, oh, okay, now you are becoming too high. So what I am doing, depending on your output, your feedback, I am reducing now at to 80,000. You said, no, it's not going in that way. It is a bit more less. I'm going to 78,000, something like that. So this is how it happens. You are approximating something, and you are getting the feedback, and that difference is being back propagated. And finally, I am updating my estimation. So this example, please let's try to understand. So we have Q table, QSA. What will be the value for Q3? 1. 3 is here. What is 3? 3 is the state for S3. For SA1, what is the value? It's a plus 5.31. But in DQ network, you don't have something table like this. So what will happen? You give QSA, Q31 to your neural network, and it will say for A0 and A1 what will be the value. You will get something like that, plus 2.33 and plus 5.311. And then finally you can see that for A1 the value is high, more compared to A0, then you are going to select A1. So this a slide is explaining everything. If you can, correlate between the Q table and DQ network. Right. So this. So if you have, let's say, 10 number of actions, so it will be A0, A1 to A9, right? And finally it will select some state which will give you the highest reward. So here we used to put softmax. So softmax, what it does, it says you the probability of each action, and this is how it will be calculated. You just do E of x by E of nx. So it will be E of 5.31 by E of 5.31 plus 2.33. So finally the sum number will come between 0 to 1, and this is the probability which action should you take. So finally, so vector would look like for A0, let's say probability is 0.2, for A1 the probability will be 0.8. So finally you get to know, okay, I should go with A1. So this is how network look like. You will have so you will have this word, and word information is like current environment you have. Your state, you will have something, you are passing it to the neural network, and you will say, okay, you do just add max over it, and you will get to know which action you should take, right? And finally that action will go to again to the environment, and your state will be updated, and you will go like that. So this is the idea of DQ network. So I'll explain also the algorithm, but before that I'm going to say what is the DQ network. So I saw the modules, and the professor has first taught about deep learning, and then about deep reinforcement learning, and also some ethics at the end, right? So this was the agenda, if I remember correctly. So you will have some experience replay memory. Please try to understand slide card, because this, if you will understand this slide properly, you will be able to know what is the deep neural network, that algorithm. Because I will explain through this one, but it will be easy to grasp the idea from this slide itself. So what is it? If you see, I have Q network. I have some network. If you remember my example, I was saying whatever estimation I do after 5 days, more likely I will be better if I am learning. So here also you have some target network and Q network. Q network is my current estimation, and target network is, Q network is the behavioral network, and target network is whatever you have freezed. So let's say after 7 days I am doing a checkpoints of my learning. People used to do like that. So on Sunday I checkpoints. I said for going out to the movie, it may give, let's say, 100 rewards, something I decided like that. After 3 or 4 days, maybe on Thursday, I get to know going out to movie was not a good action. It would be let's say cost of 70 something. So I'll just do here, target network would be whatever estimated I have done on Sunday, and currently whatever I'm estimating is the Q network. So it's 100 minus 70. So this is the difference between your behavioral network and target network. So target network means whatever estimation I have done on the Sunday. Q network means whatever estimation I'm doing now, the Thursday. Does it make sense? I think so. If you get any doubt, please feel free to interrupt me between. Now coming to the algorithm part. So I'll explain, but before that, just give a minute and you people read the sentences. Okay, so let me explain. So initialize your replay memory. What is the replay memory? As I said, you have some bookkeeping you will do in that table. So this is known as experience replay. So what will be saved in experience replay? If you ask me, so experience replay would have collection of tuple. What does tuple consist of? The tuple will have 4 or 5 information, which is state, action, next state, reward, and whether it was final state or not. So this tuple would be saved here. So you are going to start learning, fine. So you are in state S, third floor, you took an action up, you went to fourth floor, you got a reward of +5. Was it terminal state? No. So your tuple would look like third floor, comma, what was the action? Action was up, where you went, fourth floor, what was the reward? +1, let's say. Whether it's terminal state or not, it was not terminal state, that way it would be 0. If it would be terminal, then it would be 1. Fine. So this is how it works. So each tuple will be like that. So each tuple will be collection of this information. So why, someone can ask, why are you storing this information? Because when I'll do the training, what I'll sample the states and I'll get to know what was my previous prediction and what I'm doing right now, and do the difference and do the back propagation. I will explain that part as well through the equation, but this is just general intuition I gave you. Now coming to the equation, you are initializing all that memory. Let's say initially everything is empty. You have neural network, you have 2 neural network, one is known as the target, one is known as the behavioral. Behavioral means what is currently I am doing, and target means freezing at each 7 weeks. It is not 7 days, it may be training time, it may be number of samples, like that. But I have given you unit in terms of days. So you are initializing both the network behavioral network and target network, right? With some random parameter. Initially, everything will be random. You did it fine. Now I'm asking you to train the model for m episodes. So you are saying, okay, model, you learn from 1 to m. Good to go. So maximum episode steps in a episode could be, let's say, capital T. So it's saying for t equals to 1 to t, you do these things. What to do? So it's saying with priority epsilon, select a random action. So we decided every time you cannot do exploitation. Exploitation means I am doing greedy. Whatever I have done, I'll just do action like that. But in new environment, you need to learn because you don't have information about that environment, right? So it is saying with epsilon priority. Let's say 0.1, I'm putting an epsilon to do. So 10% time you do explore, but 90% time you learn, do from your learning. So with epsilon priority, select a random action. So so in terms of code, I have to explain. So it is like you are generating a random number between 0 to 1, and you are checking if this number is less than 0.1, then you will do a random action. If it is greater than 0.1, you will pass the state to this equation A equals to RMS, and you will select action from there. So the example was very clear. So let's say I am here in Patna. Which restaurant should I go? I have already explored few things. I know which action I should do. So I am deciding restaurant from my learning itself. So this equation QSA. But if I went to some other city, let's say Delhi, so what should I do? There is most likely I should do exploration. That's why I say in new environment, epsilon used to be very high because you are learning there everything. Learning whatever I have done in Patna, that may not be in Delhi, right? So given the different two scenario, you need to change your you need to do exploration as per the given environment, and you whatever you learned there, you exploit that information, right? Execute action 80 in emulator. Emulator means simulator you will have, because real world you don't get the environment like that. So you do the action based on that. So you are executing that action 80 and you are reaching to another state called st plus 1. Fine. So you went to another state st plus 1. You have reward. You get some reward for that, right? So let's say reward you are getting R. So your tuple would look like st comma 80 comma st plus 1 comma rt. Whatever reward you will get it here, and another information will be whether it's a terminal state or not. Why you are tracking terminal state? Because if you are tracking terminal state to get to know whether we should end it here or not, for that as well. And also it will give you the information that if you are reaching to the terminal state, then you can think of whatever action it has taken in last 5 minutes or whatever, so forth. It was quite good, right? Because that's why you are reaching to the goal state. So now that's cool, everything. Here the main learning part comes from. So y of j is whatever, it's just difference between two things. Prediction today and prediction whatever done before 7 days. So this difference you are doing the MSA and back propagating this. And after each 7 day you are updating the network weight. Means on Sunday you will your parameter for the behavioral network and target network will be equated to each other. Means with what I am learning? Behavioral network. So after 7 days I'll update the target network because it was freeze, right? So I say, oh, target network, I have learned also new things, so now you should mimic this behavior. So this is the graphical representation, right? So just think for a second and then I'll explain. Yep. So let's come here. So this is how the tuple look like: current state, action, reward, and next state. Another information we also stored whether it's a terminal state or not. It is not displayed here, but I already run these algorithms so many times for the different problem, dialog management, and all those. So there used to also some other information, which is whether it's a terminal state or not. This is another information we used to store. So you see that first step is that you are taking the current state S6, you are passing it through the network, and you are checking which action is giving the maximum reward. So Q7 is highest, then you finally decided A7 I should take. So you are taking, selecting ready this action A7. You are passing it to your memory. What is the second step? It was A. So you follow this thing. What is B? What B has to be done? So you are executing that A7 into the environment, and you are observing another next state S4, and the reward you are getting for that is R5. Fine. So C has been done. Now coming to D, what has happened? Now your tuple look like that. Your initial state was S6. You took a action as A7, and you got a reward of R5, right? And finally you reached to the S7, like that. So this is how your tuple look like. So till D everything is clear. Now coming to E. So now training comes. So till then was, approximation. Now comes the training part. In memory, every time you are saving this information S6, A7, R5, and S4, right? This tuple. At training time, what we'll do, we'll just randomly sample, batch of random sample. We'll take few experiences and see how good or bad they were, right? So we'll pass it to Q network. There were the two Q network. One was behavioral, or if it is not written behavioral, you assume it as a behavioral. Another was the target network, which used to be phrased. So what you do here in training time step 1, if you see, you are passing this S1, this initial state, to your Q network. Means the behavioral network, means after learning, let's check what is the action you are taking. So you are passing it to there, and it is saying you should do Q4, right? We pass S1 and saying Q4, but here if you see, we passed, here it was also A4, that's good. But reward will be different, I guess, that's why they are showing this information. So A4 we have, and what is this value? It's a Q prime 4. If you can, see the value, it's a Q prime 4. Initially it was Q4. So this difference is the value if you see. So there, from target network we have this reward. Immediate reward R1 plus gamma into max of, you are going to another state. Why they are calling it as a okay. So they are putting it as like that, maximum of Q1, Q2, Qn. This will be the target value, and for this it's pretty small. It's not clear whether it's a Q3 or Q4. I'm not sure. So idea is that, so after 3 or 4 days you are going again to your behavioral network and seeing from target network prediction was, let's say, A, and from this it's A prime, and that difference is something you are saying my model should learn. This is the intuition. And you see this MSE, mean square error, is that they are doing. So you are saying initially I thought of, let's say, Q prime, and currently I am calculating R1 plus gamma into something. So this difference should be back propagated. So I'm not sure. So from where they are taking, let me make sure. Yeah, Q prime 4, they are taking it using behavioral network. Yes, correct. So they are taking Q4 from behavioral network, and they are calculating this value from target network. This is the difference. R1 plus gamma into this one. Right. Now time step 2. So it was initial one phase learning, and I was saying after 7 days you update both the things. This is what they are doing. After some time step you update these things. So you update the value of your target network with the behavioral network parameter. So this is how the DQ network works, DQN. And till your course there will be not much more than Q learning and DQ learning. So I think this will be good to go. So, last few things which is very very important is ethics in AI. I should definitely cover a few things about that. So, this is one scenario. Who loves AI? Everyone is like this. The AI machine learning enthusiasts, even though they are doing software engineering, but everywhere it's like a stuff, and the trending thing is machine learning and deep learning. So AI is everyone loves. That's cool. But who is willing to deal with the ethical guidelines of AI? No one is going there. This is just one example. It's not the true case that everyone is not going there. There are already lot of groups who are working on fairness and all those things. So who is willing to take the responsibility, decision, and algorithm? Uh, People are still thinking about that. So this is the current scenario of ChatGPT. If you are following the current trend, GPT-4 has launched. That's cool, but so much information, so much advancement in last 3 months left people, in lot of kind of different space. Not only the researchers, but also to the common people. ChatGPT, if you have used. So there will become one group that now AI advancement should halt for 6 months. So lot of big researchers said let's halt AI advancement for 6 months. But again, one group is saying why we should do halting and also. So there is again discussions going on these two things. In the morning itself, I saw a very nice post, so I should mention it. So it was three things. Initially, who were strong with the bodies, they get lot of money. Means they are the superior in our world. Nowadays, who have more brain were superior, superpower. Now, in few months or years, someone posted that it will be heart only. That heart is the only unique thing with the people that machine will not have probably. So this is, you see, so body power to brain power to heart is something you need to do with the passion things, and those job would be only there in market. Others would be replicated easily through some assistant or AI model. So this is very depth statement, you should think about that. So muscular body to intelligent brain to a passionate mind or something. So how this transition is happening. So AI, what few things we should consider in ethics is the privacy. You should not disclose privacy of the people. They are giving you data doesn't mean that you are going to disclose them. For example, ChatGPT, you are searching so many things, maybe some medicine, maybe some family issue, something like that. So these are your very sensitive content and data that should not be utilized or even made it public. So this is the privacy concept. Accountability. The team working with the AI must own the responsibility of the decision and taken and the consequences. You are making autonomous driving car, that's cool, but there is also risk factor that you should also account. Means to make models so that the risk factor should be minimal. So that accountability should also be done. Safety part. Coming to the same example, you are not going to on a road who have lot of crowds, because if there is another safety concern, something. Transparency. Nowadays people are not considering. It's my experience, I say, but it matters how data is being flowed, how everything model has decided. Those things kind of, it's also comes something explainability there. So people are now want the task should be done rather than how it is being done. So but in long term, transparency matters as well. Respect for human values. This is the core. So I used to say you will be doctor, engineer, scientist, but you need to be good human. This is the most important thing, and everything would be the secondary. So you need to respect the human values, different emotion, people, and all those. This needs to be considered while making something extraordinary, which needs to be interact with the human and all those things. Fairness. No discrimination based on the gender, race, and caste. Yeah, your model is saying 3-year punishment to, let's say, ABC people who is in gender male, and someone with the female saying 2 years of jail for same kind of case. It doesn't make sense, right? So fairness should also happen. There should not be biasness towards gender, race, caste, and creed. These things. So I think you people are knowing that how AI has started. All started with Turing test, So making something like a human. So fine, this is still on. A race is going on. Can we make a humanoid? Can it act quite similar to human? So still way to go in this approach. Way to go, and advancement will happen. So what are the basic rule while making a robotics is as follows. If you see, a robot must not injure a human. This is the first principle. I don't know whether you people have watched this movie. It was Ex Machina, I guess. So there was. So whoever made the robot, I think at the end, it killed the inventor itself. So it should not do this kind of thing. It should not harm human. This is the basic first principle. Must obey the orders given by human beings. So it should follow the order given by human. This is the thing. A robot must protect its own existence. So see, third point is coming after first these two. So it's not like killing someone for its own existence. It should also be a mistake. It should be killed but doesn't make harm to the people. So this is the third point. It should protect itself, but after these 2 points, these are two more important. For protecting itself, should not harm the people, but yeah. So just recall the human rule. In protection of yourself, you can kill someone as a like that. There is some rule or what I do. So it's not applicable for robot. Something. So it must do these three principles. So for making a humanoid is still far away, I believe. So now few questions people have from deep learning and deep reinforcement learning. So in deep reinforcement learning, mostly you are learning why deep learning is required for reinforcement learning, first phase, and second one is how Q network will be done using a neural network, which is known as deep Q network. These two things, and third was AI ethics. So these are the three things were in your current session. So which of the following Boolean operations on two variables can be represented by a neural network? Using ReLU activation function. ReLU is a non-linear function. So it is asking, I'll give you a neural network with only one hidden layer. It may have a number of neurons, let's say. And the activation function would be ReLU. Which function you will be able to implement? AND, JOR, or NOR. So these are the options. Think for a moment and let me know. Then I'll discuss. So let me say. So it is saying you will have a function, you give two information x and y, which operation could it do? Will it be able to do and? It's not only one thing is asking, which are the function to able to compute and, join, or and not. So this is the question. So now coming to the answer, the four all function could be done because there is a non-linearity here, that radio information. If I had asked you not removing that information radio, then I think join and not you will not able to compute, but and or you can compute. So this is the trick. This question may reverse in that way. So this radio information may here it is a trick. It is a non-linearity. So I think you people know what is the linear and non-linear function and all, right? Linear function and non-linear function. Non-linear will have the lot of power. Next question. If Jz is the tanh function, which of the following is the correct expression for the derivative with respect to z? This one you people are able to easily do it. Now you let me know. This equation was, this question come to various exam. You should tell this one. Please calculate it. So if you don't know tanh, then you should first see what is the tanh function. Then you do the derivative and see which one it is following. This is interesting finding. So derivative of tan should be expressed in its tan terms. So yep. Is it done? Chaman?
So tan x function, you know, no, is e of x. If tan x, if I have to write, it's e of x minus e of minus x divided by e of x plus e of minus x. Then do the derivative and express it in terms of whatever initial function you have. So I'm just writing the clue. You start doing that. Tan of z equals to e of z minus e of minus z, this one divided by this whole one, but in plus sign. Yes. So this is the tangent formula. Now you just do the derivative and express it which one this function is following. Please do it, it's not that difficult. I want the solution. Okay, so let me solve this problem for you. So just one differentiation. So you have to differentiate this function. Right. So your gz is this one. Z is this one. Yeah, just differentiate it. df. Sorry, it's not the symbol mistake if it happens, please, because of this I have to write it here. So there might be some operation mistake. So that will please point out. So dz by of d of z, which will be, so differentiation of 1 by x is what? X by y is differentiation of your x given y is a constant minus of the reverse term and divide by square this term, this one, right? So it should be like this one. Whatever we have this one, it will be like this only, but one square will come. So the square will come, and then you differentiate. If I recall it correctly, d of let's say x by y. I'm not writing that term, so it will be y square would be, I know, denominator, and d of y would be as a constant. D of your x term minus of your x would be constant, d of your d of y. So this is how it look like, and below it will be y squared. Okay, so I might be mistaken something, but if I could recall, this is the formula. So this formula will just put it here, and then if you simplify it, you are going to get this one in the formula. So finally, whatever this expression you will get it, if you express it, so finally it will look like something like that: e of g of z whole square. So what is g of z here? G of z is whatever the g of z we had. So this term. So finally differentiation would also look like this thing something. So your answer would be this one, D. Right. Going next, which of these accurately describe ReLU activation over tan H? Which of these functions, if you see these options, accurately describe ReLU, means just a kind of comparison between ReLU function over tan H. So what are the advantages, you have to say? Just think for a moment and
So, anyone want to attempt this question? Which of these accurately describe ReLU function? These are two activation function for 10H we said. And ReLU just compare whether it's a faster to compute, reduces gradient vanishing problem. What is gradient vanishing? Gradient vanishing is that I said you. So at the end you calculate the error, right? Predicted minus, let's say, target, and square, let's say, back propagating through a neural network. So what it happens, you find we have some error, but every neuron or the weight you will have, the age, is not equally responsible. So depending on their weight parameter, it is getting updated accordingly, right? So what happens? Gradient vanishing says if your gradient is very less, then over the time when you will go backward, it will become very close to 0. This is the gradient vanishing problem. If some number is between 0 to 1, and if you multiply with again smaller number, it will less and less, and at the end it becomes very close to 0. So this is known as the gradient vanishing problem. Value is a continuous function, doesn't saturate at the high values. So over these 4 options, which are the best describe ReLU compared to tanh, you have to select. Now I gave you a few clues about that, so I think now you can attempt and say what would be the answer. Okay, so I need to attempt it. So the first one is faster to compute. That's true. It's true about ReLU function compared to tanh. So it is easy to not easy, I say fast in operation, in terms of operation, reduce gradient variation. So rather than making this one, this problem also exists. It not problem, sorry, reduces gradient vanishing. So this problem it reduces, not it occurs if you use the value compared to tanh. Does not saturate at the high value. So it has asked which of the following are correct. So these 3 options. ReLU is a continuous function. It is not true. So over all 4, this is the correct one. Next question. The number of nodes in an input layer is 10, and in the hidden is 5. The maximum connection from input layer to hidden layer are. So there are, let's say, first is the input layer, and it has the input layer is 10. 10 nodes are there, n1, n2, n3 and n10 are there, and the hidden layer is there just after it, and it has the 5 nodes. So it is asking how many connection maximum can it have from input layer to hidden layer. This is the question. Will it be 50, will it be less than 50, will it be more than 50, or it is an arbitrary value? So that over these 4 options, which one is correct, that you have to say.
Yeah, please. So I think question is clear. The question was, so you have input layer, you have a neural network, and it consists of 10 nodes. Another layer is there after that, and it has 5 nodes, the hidden layer. So it is asking, there used to be age between, input to hidden layer. So the question is asking, let me explain. So this is the scenario. So this is the scenario. So you have something like 10 nodes. Huh? How much node is this? Let's make some dot 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 is there. Some dot 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 is there. So there are 10 nodes, and in the second layer there are how much? 5 nodes, I guess. See, so in the followed node you have 5, sorry, you have 5, 4, 5. So this is the scenario. So it is asking, there used to be is between node. So how many maximum, connection can it have? This one it is asking. So from this it can go to this as well. It go to this as well. Right. So this is how. So for this node can go to any of these 5 nodes, right? This one also can go to any of the 5, even all 5 at maximum if you are calculating. So maximum layers, maximum edges could be for 50. For this one it will be 5. For this one it will be 5. For 10 it will be 10 into 5, which is 50. So answer would be at maximum how much? It will be coming towards 50. Right. Now this is one nice quote I had read somewhere. So many are concerned about the lack of AI expert these days, but the lack of real thinkers and philosophers is even more alarming. So this is put a different impression on me. So nowadays we're thinking about AI expert. That's fine, but you need something more than that. So you need to have thinker and philosopher who are making this kind of AI experts. So rather than specialist, you need to have general idea for a given scenario what could work, something like that. So that philosophy and thinkers are more important than AI expert in this scenario. It says like that. So it is, someone said its name is Murat. He is the CEO of AI Soma. So this quote, please take it seriously, that if you are a thinker and philosopher, you can find solution to any problem. But if you are any AI expert, then you will be constrained to that. So this is the difference in mean between these two terms and sentences. So take it like that, please. Right. So if you have any question, any suggestion, feel free to ask.